Right. So today we are going to discuss about the software architecture, especially whenever we are designing any kind of large-scale systems, all that. So this is something which you can see over here. Before I'm getting into this, first of all, let me explain you what software architecture is all about. Majorly, it's a high-level description of a system structure, which majorly defines the interconnection and as well as behavior of the subcomponents, uh, which is something useful for us to make up the system and all. In order to fulfill any kind of functional requirements, at the same time developing some complex implementations, everything will be part of software architecture. The major advantage in developing software architecture is to handle the process and storage of large amount of data. At the same time, thousands of users can serve every day. So these are the major advantage. Like the best example you can see, like the kind of social medias we are using now and then. At the same time, if there is any kind of online video games or banking systems, core banking solutions, also all that, right? These are all something an examples I can give in context to the software architecture itself is concerned. If you want to develop a software architecture, whenever if you want to gather any kind of requirements, there are different features of the system that are involved. You can say like some functional requirements, like what are the different functionalities that are required for us to develop a system architecture. Next, quality attributes, majorly in a form of non-functional requirements. It can be scalability, it can be availability, reliability, security, performance. All these are comes under the quality attributes. Next, system constraints will be taken even because the kind of limitations as well as the kind of boundaries we have. It can be even financial boundaries also. These are the major aspects or major steps or major requirements I will suggest to everyone. So because if you want to develop a software architecture, these are the major ones are needed. One is about the functionalities, non-functionalities in a form of quality attributes and all. And what could be the system constraints? Everything comes under this. But when it comes to the system constraints are concerned, because when we want to develop it, if you want to know about the system constraints, like for example, normally system constraints majorly considered for us to design and construct a pillar of the software design right from the starting point, right? So how the system is designed, right? So what are the different type of system constraints do we have? Technical constraints, or it can be a business constraint, it can be a regulatory constraint. Like technical constraints, let's say that there is any kind of particular hardware vendor or something like, or if there is any kind of business constraint, something wherein if you want to follow any kind of deadlines or the limited budget. Regulatory constraint may be some general data protection rules, or if you want to collect or store any kind of sharing of usage of data. These are all comes under the regulatory constraints. So these are the major elements which we need to do or which we need to understand when we are developing the system constraints are concerned. At the same time, when it comes to the scalability, right? So uh, because the major advantages you can see, like because there is no code changes are needed. Next, all the applications can be benefit from that, and followed by, especially when we are working on any kind of migrations to different machines and all, it will be very easy. So because of the scalability, the major disadvantage I can see, like if there is any kind of centralized system we are providing, it is difficult for us to manage any kind of fault tolerances or high availabilities. Everything will be difficult. At the same time, adding horizontal scalabilities by adding more hardware servers to process the client request. Everything can be done. Along with that, especially when we develop large scale systems, especially from the architectural blocks point of view. So load balancing is one of the key and important area we need to be focused on. Next, what are the message brokers we have, followed by any kind of API gateways we have. So everything will be taken into consideration as far as the non-functional requirements, followed by availabilities, at the same time understanding system architectural blocks, everything are concerned, especially load balancing, message brokers, API gateways, all these things will be included in this. But to understand the software architecture, how to build this, there is always important for us to understand this from the use case. Use case learning is essentially required. That is what something which we are going to discuss in our workshop. On this weekend, I'm conducting a workshop where we will be discussing about uh, how this can be implemented practically. Uh, we need to have some example. By taking one example, I can create some software architectures the way you can see over here, and I can explain. So this is majorly useful to you because I could see many people are from technical background, majorly from the programming side. For the people who are from the programming side, is essentially is more related because if anybody wants to move towards the architecture side, uh, this is something essentially required. Okay.